This video provides an explanation of the AP free response problem that we worked on in class on Thursday. The videos that you're going to be making for your AP free response problems should be similar. So in this problem, we were given the equation 4x squared plus y squared equals 28 plus 3xy. It asked us to find dy dx for part A. So I'm going to take the derivative, do the derivative of 4x squared. I bring down the 2 and multiply by 4, which gives me 8x. Technically, we're doing the derivative of x as well, dx over dx, but that cancels. Plus, derivative of y squared, bring down the 2, becomes 2y. But we're differentiating with respect to x, so this has to also have dy over dx. The derivative of 28 is 0. Here we have to use the product rule to take the derivative. So my two functions are 3x, which is sort of my f, and y, which is g. So I'm going to take the derivative of f. The derivative of f is just 3. And multiply it by g, which is just y. And I'm going to add f, which is 3x, times the derivative of g. The derivative of g is just 1 times dy dx. So we're taking the derivative of y with respect to x. Okay, so let's simplify this. We now have 8x plus 2y dy dx equals 3y plus 3x dy dx. Since we're solving for dy dx, we want to get these two expressions on the same side, or these two terms on the same side of the equation. So I'm going to move this one to the right side, and I'm going to move this to the left side. So subtract 3y from both sides, I get 8x minus 3y, and I'm going to subtract 2y minus dy dx from both sides. I get 3x dy dx minus 2y dy over dx. Next up, I'm going to factor the dy dx out of these terms. So the left-hand side stays the same. Here I get 3x minus 2y times dy dx. So I factored that out so that I could get it in a step alone. So now to get dy dx alone, I'm going to divide both sides by 3x minus 2y. So let's move this up a little. Divide both sides by 3x minus 2y, I get 8x minus 3y divided by 3x minus 2y equals, and if I've divided both sides by this expression, this side will disappear, or this expression on that side will disappear, and I end up with dy over dx. Okay, so that's our answer to part A. That is the derivative. Dy dx is equal to 8x minus 3y over 3x minus 2y. The next part of the problem, B, asks us to find an equation for the line tangent to the curve at point -2, 1. Okay, in order to write the equation of a line, I'm just going to do this in point-slope form. So this is the general form for point-slope. I need to find my slope to plug into the equation. We know slope is synonymous with derivative, so I need to find the derivative value at -2, 1. So we had said that dy over dx was equal to 8x minus 3y over 3x minus 2y. Now I'm going to take the derivative specifically at -2, 1. So I can plug in the x and y values. So now I have 8x, which is 8 times negative 2, minus 3 times y, the y value is 1, over 3 times negative 2 minus 2 times 1. When I plug that in, I get negative 19 over negative 8. That simplifies to 19 over 8. Okay, so now I can plug that into my equation. So I'm using this equation for the tangent line. And it is y minus y1. My y value is 1 equals, the slope is 19 over 8 times x minus x1. x1 is negative 2. And we know when you subtract a negative, it's equivalent to adding. So my final equation, y minus y1 equals 19 over 8 times the quantity x plus 2. So that is the answer to B, the equation of the tangent line to the curve at negative 2, 1. Now on to part C. We're going to get a fresh page for this. Okay, part C asked us to show there is a point R with x coordinate 3, at which the line, sorry for the messy handwriting, that is tangent to the curve at R is horizontal. And I'm going to abbreviate that. It's horizontal. Find the y coordinate of R. Okay, so when I read this, the first thing I think about is an image or a sketch. So we've got some kind of curve. I'm just going to draw it like this, at which there is a tangent line that is horizontal. So at this point, if I have a horizontal tangent line, that means that I have a maximum or a minimum. I just drew it as a maximum. So I have this tangent line where the line is horizontal, so the slope is 0. So dy dx I know is 0 for this point R. So I'm going to label this as R. I also know that the coordinates for that point are 3, comma, some unknown value, y. Okay, so it asked me to find the y coordinate. In order to do that, I'm going to have to use what I know about the derivative. So I know from the previous problems, oops, let me get a different color. All right, from the previous part of the problem, I know dy dx is equal to 8x minus 3y over 3x minus 2y. We know for this specific point here at R that the dy dx value, the derivative, the slope, is 0. So I have 0 equals 8x minus 3y over 3x minus 2y. Okay, in order to solve for y, I am going to multiply both sides by 3x minus 2y. Okay, when I do that, the left-hand side is still 0 because anything multiplied by 0 is 0. And these terms cancel out, leaving me with 0 equals 8x minus 3y. Okay, I know what the x value is. At this point, it's 3. So I can plug in 3 for x. So I have 0 equals 24 minus 3y. That means 3y equals 24. So y is 8. It asks me to find the y coordinate. So the y coordinate is 8. Next up, we're going to go to part D. Part D asked us to find the second derivative. Oops, that's a squared. D squared y over dx squared. So that's the second derivative at the point found in C. Okay, the point found in C, we just found that. It was 3, 8. So we are finding the second derivative at point 3, 8. So let's put what we know down. We already know the first derivative. We know that it is 8x minus 3y over 3x minus 2y. We're going to need that derivative in order to take the second derivative. And another key fact is we know at this specific point that that derivative is, well, we can calculate what it's going to be equal to. We know it's already equal to 0, but we could plug these points in. But we know there's a horizontal tangent line, so we can just say the derivative is 0. All right, when I go to take the second derivative, I'm going to have to use the quotient rule. So I have a function up top and I have a function down below. So the second derivative, I'm going to take, so let me just label this as f, g. We know the quotient rule looks like this, all over g squared. Okay, so using 8x minus 3y as my f, I'm going to take the derivative of that. It is 8 minus 3 times dy dx. And I'm going to multiply that by g, which was 3x minus 2y. Subtract f, which is, I'm running out of space, 8x minus 3y times the derivative of g, which is, so I'm taking the derivative of 3x minus 2y, so that's 3 minus 2 times dy dx. All of that over g squared, so all of that over 3x minus 2y quantity squared. All right, the great thing here is we already know dy dx is 0. So if we substitute 0 in here for dy dx, this part completely disappears because 3 times 0 is 0. And if we plug in 0 here for dy dx, this part disappears because 2 times 0 is 0. So that's going to simplify things for us. Okay, so now this is equal to 8 times 3x minus 2y minus 8x minus 3y times 3 all over 3x minus 2y squared. All right, now I can start distributing. So I have 24x minus 16y. Then distribute the 3. I get, and I want to make sure that I put my parentheses here because there's a negative out front. So I get 24x minus 9y, all of that over g squared. Okay, so looking at this, I have a 24x minus a 24x. Those cancel. So I have negative 16y minus negative 9y over 3x minus 2y, that quantity squared. So finishing up, the second derivative is negative 7y over 3x minus 2y squared. And that's it.